Alright, we're going to get started in section 1.6, transformations of graphs. Now we've already done some graphing, and as you can see up on the board I have 9 basic functions graphed out. These are sometimes referred to as the parent functions because a lot of what we deal with, a lot of what we graph in pre-calculus, at least until we get to the trigonometry part of pre-calculus, we're going to be using some variation of one of these parent functions. So it's good to be familiar with them. We have a linear function. Notice there's no scale that I put here because I didn't want to draw a specific one. This is y equals mx plus b. This is an oblique line. But then we also have the constant function, which of course is a horizontal line. Again, no scale. After that, we get to the identity function. The identity function looks like a kind of a diagonal that goes right through the origin, cutting the first and third quadrants kind of in half. You've got the quadratic function here that's the shape of a parabola, f of x equals x squared. As you can see so far, the domains of all these functions are all real numbers. You've got the cubic function, which is kind of this little snake-like S-shaped curve here that's kind of sideways S anyway. And notice the scale here is a little different. I put a 2 here on the y-axis so that I could reach the point 1, 1 and the point 2, 8 as part of the graph. I have the square root function that's supposed to be a little arrow on the end that's not a point. And what that is, of course, it has a limited domain because you can't plug in a negative number in for x. The domain here for this function would only be from 0 on up, or all non-negative numbers, all non-negative real numbers. Then you've got the cube root function. Now because it's an odd index, you can plug in positive numbers or negative numbers. And again, I changed the scale a little bit there to accommodate a couple of extra points so that you can get the basic idea of the curve. You can kind of see this curve kind of just reflected in the identity line there to give you this one. The absolute value, I always remember V for value and the V shape here that has a corner point or a cusp or a vertex at 0, 0, the origin, and then it kind of looks like the identity function here in the first quadrant, but the identity function stops because this part's been reflected above. Remember, absolute value, when you plug a number, positive or negative, is always non-negative. And then the reciprocal, this is kind of a different one because it also has a somewhat restricted domain in that the domain cannot include 0. You can't plug 0 in for the denominator there. And as you can see, although my graph is engraved, these go on forever. There's supposed to be little arrows on the ends. The x and the y-axis are what we refer to as asymptotes. We'll talk about that in more detail as well. Now, if all we had to deal with were these 9 parent functions, we'd be great. But as you already know, there's a lot of other functions that are variations of this. And the variations are what we refer to as transformations. There are 4 main types of transformations, one of which we're not going to look at in this section, and that's rotations. But we're going to look at translations, which are kind of like shifting the graph. We're going to look at reflections, which are kind of like flipping the graph across the x or the y-axis. And we're also going to look at what we refer to as dilations, where we stretch or shrink the graph, either vertically or horizontally. But we're going to start with translations. They're probably the easiest ones, and I have some examples here. But very key for the translation is, if you have a function y equals f of x and k, that's supposed to be a lowercase letter k, is a positive real number, then the graph of, you see right here, y equals f of x, the parent graph, plus k, is the graph of the parent shifted k units upward. Okay, plus k positive, that would make sense. Upward seems like a positive idea. The graph of f of x minus k is the graph of the parent function shifted k units downward. So remember, k is a positive number, so I'm subtracting a positive number there. It's going to look like a negative with that subtraction sign, and that kind of gives you a clue on whether you're shifting it upward or downward. So let's consider first this graph right here, g of x equals the square root of x minus 2. Now, here's the parent graph, g of x equals the square root of x, which is this guy right here. So we know the basic shape here. Remember, this is an arrow that goes on forever and ever and ever, kind of upward and to the right. Well, we're going to have that same basic shape, but we're going to shift or translate
shift is easy to remember. Slide back and forth, upward, downward. In this case, we're doing vertical shifts. We're going to slide it upward or downward. With a -2 there means that the graph has been shifted down 2 units. So I'm going to put this one here on this graph, and all I'm going to do is take this graph. Now notice here, this is at 0, 0. If I move 0, 0 down 2 units, I'm at 0, 2. That's right here. If I move, I have the point graphed 1, 1. If I move that down 2 units, I'm at the point 1, -1. And then I have the point here, 4, 2. If I shift that down 2 units, I'm at the point 4, 0. And you can see it's the same shape, it's just been translated down 2 units because of the -2. Now, the next part has a +3 here, which indicates to me that it's going to be shifted upward 3 units. So I'm going to go through the same steps. 0, 0, back on the parent graph, is going to be up here at 0, 3. 1, 1 is going to be up here at 1, 4. And 4, 2, 4, 2 right here is going to go up to 4, 5. And that's why you're going to use graph paper when you do your graphs on this, because this freehand stuff is sometimes very difficult to follow. So do your very best to use graph paper and draw your curve. So that's this one here in green, and that one down there, that's this one here in orange. Orange marker doesn't seem to want to work. Now, we also have to consider not just shifting it upward or downward, but shifting it to the right or to the left, horizontal translations. So again, we start out very similar, and we're going to use a different variable. We're not going to use k. Consider a function y equals f of x. Let h represent a positive real number. The graph of y equals f of the quantity x minus h is the graph of y equals f of x shifted to h units to the right. Now that might be a little confusing because you see the minus h, and when we had the minus k, it went down. You would think minus h would be to the left, because kind of to the left is negative, to the right is positive. But it has to fit this format, x minus the number. So the number, if h is positive, you're going to the right h units. Whereas the graph of y equals f of the quantity x plus h is the graph of y equals f of x shifted h units to the left. So inside the parentheses, it's kind of the opposite of how it looks. Outside the parentheses, it's kind of exactly how it looks. So I'm going to do here a couple more examples. This first example has only a horizontal translation because you're subtracting 4 from the x. You're subtracting a positive 4 from the x. So this is going to go 4 units to the right. So remember this guy here at 0, 0, 1, 1, and 4, 2? Well, now this minus 4 here puts 0, 0 here at 4, 0, 4 units to the right. 1, 1 at 5, 1, and 4, 2 would become all the way over here at 8, 2. And I get a graph. Oop, that looks something like that. Draw it as carefully as possible on anything that's submitted to me for grading. All right, now that's this guy right here. I'll put him in green. Okay, this one actually has 2 different kinds of translations of shifts. The +2 here that's added to the x is right here. It's going to shift it to the left 2 units. Because if it helps, x plus 2 can be thought of as x minus a -2, and that -2 means you're going to the left 2 units. The -1 on the outside of the square root sign is kind of what we had back here. That's going to shift it downward 1 unit. So remember how I started out with my vertex for my parent graph here, the square root function, at 0, 0. Now I'm going to go 2 to the left, 1 down, 2 to the left, 1 down. Here's that point now. 1, 1, 1, 1 was right here. 2 to the left, 1 down is going to shift it over here to -1, 0. 4, 2 is going to go 4, 2. It's going to go 2 to the left, 1 down. It's going to be down up here, I should say, because of the way my graph is. And it's going to look like this. as neatly as I can draw it there. Okay, I'll stop here and put an arrow on the end because of the other graph there. And you can see how the adding or subtracting of a constant either to the function itself or to the x value of the function is going to involve some type of translation, either vertically or horizontally. These are pretty subtle differences, but these are key differences, and you should try to do your very best to remember these.